Alright guys, welcome to Unit 5. Our first lesson in Unit 5 is on antiderivatives, which means that we are going to find the antiderivative of derivative functions, which means that we're kind of like going backward now. Notice that in Unit 3 and Unit 4, we found derivative. And now we're going to go backward, which is finding the antiderivative. And that's the main point of the lesson, today's lesson. All right. So think of these given functions in Unit 5, Section 1 as the derivative function. And then your goal is to find an antiderivative of it. So before we start, let's take a look at a motivating question here. So suppose that you are given the velocity function, which is cosine, and asked to find the position function. Now, if you have the velocity function, then that means that you have the derivative because velocity is derivative, right? And position function is kind of like the original function, or think of it as the antiderivative because original function is antiderivative. So if we are given velocity function, then the question here is, what is the original function, or what is the position such that the derivative is cosine? Well, hopefully you do figure that out, and that is, it has to be the sine function. If the position is sine, then its first derivative is cosine, and first derivative is velocity. All right, there you go. You got it. Good. Now, an antiderivative. Definition of antiderivative here. A function, big F, is an antiderivative of little f if the derivative of big F is little f. So from now on, when we refer to antiderivative, we are going to label that big F. All right, let's apply that to this problem. So you know that your velocity function is cosine. If we want to find the antiderivative, we now will call it big F. And so the antiderivative is sine of t. And it makes sense because if you take the derivative of that, don't you get cosine? Okay, so again, from now on, antiderivative is labeled as big F. Now, here is another question. Is it possible to find another antiderivative function whose derivative is cosine? And the answer is yes. And it turns out that there are plenty of them. For example, if your big F equals to, say, sine of t plus 5, isn't it the derivative of this equal to cosine? Or say if your antiderivative is sine of t plus 2, isn't it the derivative of that cosine? So in general, there are plenty of them whose derivative is cosine, and therefore we generalize it with adding a letter c afterward, and c represents constants, which means that it could be any one of these numbers. So notice that f is an antiderivative. It's just one of them. But in general, if f is an antiderivative, then every other antiderivative can be found by adding a constant, right? So you can have like plenty of antiderivative of a given derivative. And we generalize that with adding a c like that, okay? Awesome. Now, the process of finding an antiderivative has two different names. It's called, one of those names is antidifferentiation, anti-differentiation, right? Or here's a simpler one, integration. Integration is also called antiderivative. It's referring to anti-differentiation. There are two main branches of calculus. The first branch is the differentiation branch, and that's in Unit 2 and Unit 3 where we found the derivative. And the second branch is the antiderivative or the integration. And now we're focusing on the second and the last branch of calculus. So, this is the symbol. This is a symbol, okay? So symbol that instruct us to find the antiderivative. Okay. And this is the function that we want to find the antiderivative for. That function is called the integrand function. And this is the symbol referring to or with respect to the variable. And that variable is usually x or t. X is more generalized, t stands for time, and that's the two symbols that we tend to use for. Now, don't be scared by this symbol. This symbol only tells us to find the antiderivative, just like how, you know how this symbol tells us to add, right? This symbol tells us to subtract. This symbol tells us to multiply. This symbol tells us to divide. So that symbol tells us to find the antiderivative. Instead of saying it out, we just use that symbol to represent, say the antiderivative. Now, once you have found the antiderivative, then we call this the simplified version. Simplified version, okay, of the general antiderivative. For example, say if you're asked to, if you see something like this, then immediately you interpret that they want you to take 5 and add it to 9, right? I'm sorry, 5 added to 4, which equals to 9. So 9 is like the simplified version of 5 plus 4. Okay, so just like how this symbol tells you to sum the two numbers, this symbol tells you to find the antiderivative of that function. All right, so that's it. Now, it turns out that it is extremely easy to find the antiderivative of any power function. This is an example of a power function right here. Any function whose has the property of like x raised to the n is called a power function, and it is extremely easy to find the antiderivative of that power function. So the rule says that to find the antiderivative of a power function, all you have to do is add 1 to the original exponent. So the original exponent is n, so add 1 to it, right? And then divide that by the exponent, which is n plus 1, right? And so that's one of the antiderivative. But if you want to find the general antiderivative, then you just need to add the letter c afterward, and that gives you the general antiderivative. So whenever you see one of these problems here, they are asking you for the general antiderivative. Okay, not just one of the derivative, but the general version of it. Okay, so these are all power function. So we're just gonna follow this rule, which tells us to add 1 to the power. So So if you like, you can kind of read one of these problems. This symbol tells you to find the antiderivative. Find the antiderivative of what? Well, of x squared. The antiderivative of x squared is you add 1 to the original power, and then you divide it by the same power, and then you just add the letter c. Simplify this. This gives us x to the third because 2 plus 1 is 3. Everyone knows that 2 plus 1 is 3 over 3 plus c. Okay? Now, if you think about it, this is like big F, and if you were to take derivative of this, you will get x squared. Okay? All right. Find the antiderivative of x raised to the 3 over 2. Well, you take the original power and you just add 1 to it, and then you divide that by the same number. Now, if you were to add 1 to the power, you would need to make sure that they have the same denominator, and so 1 can be turned into 2 over 2. That becomes x to the 5 over 2, and then you divide that by the same power, whatever you came up with for the numerator, and then you add a c afterward for the general antiderivative. Now, whenever you divide by a fraction, then it is the same as multiplying it by the reciprocal. So the most simplified way of writing that is to write it like this, like that, because dividing by a fraction is the same as multiplying it by its reciprocal. And you can also write it like this too. So you might see a variety of different versions of how you would express this answer, but either one of those will suffice. Awesome. Okay, the integral of 1 over x squared. The integral of 1 over x squared, usually what I do is I turn it into a power function, and then I'm going to go ahead and apply the power rule to it. Okay, so when you do add 1 to the original power, and I'm also going to divide it by the same power, add a little c. This becomes x to the -1 over -1 plus c, like that. And then negative exponent can be simplified to 1 over x. The -1 is now there. And then I just put followed by that plus c. Okay, awesome. In the next part, we'll go over these couple of simple rules, and then I'll walk you through a few other examples.